Today in this video, in this next section of our packet, we're going to be talking about the standard deviation a little bit more. What does that mean? We learned how to find it on our calculators and our other section of our notes. What are histograms? And we're going to introduce the normal model. So the first thing is standard deviation. So yesterday we learned how to find that in our calculators. Remember, it's one variable stats and then it's the s of x, okay? And what basically this does is it measures how spread the data is around the mean. So if the data is all kind of real close to the mean, it would have a smaller standard deviation. And if the data is spread farther apart from the mean, it would have a larger standard deviation. So the first thing I want you to do is take a look at these two separate sets of data. First of all, they both have the same mean, and the mean for both of these is 10. And if you kind of look closely, you can see why. 10 is the number in the middle. But one of them is more spread out around 10, and the other one is closer in towards the 10. So without doing anything in your calculator, I want you just to decide which one would have a smaller standard deviation and really which one would have a larger standard deviation. So take a minute to think about it. If you need to pause the video, pause the video. But what we get here is basically 10 is in the middle, and these guys go from 0 to 10 to 20, whereas these go from 9 to 10 to 11. So 9 and 11 are much closer to 10 than 0 and 20 are. So this guy would have the larger standard deviation, and this guy would have the smaller standard deviation. And now what I want you to do is calculate the standard deviation for each of those and confirm that that is the case. So I'm going to clear out the data that I have in here from a previous problem. Remember, cursor on top of L1, and then press clear, not delete. And my first set is 0, 0, 0, 10, 10, 10, 20, 20, 20. If you haven't got those in yet, pause the video, and then stat calc 1. And you can see that mean of 10, like I told you, and then S of x is 8.6. So this guy's standard deviation is, can round that up, 8.7. Now for the other guy, stat edit, I'm just going to type right over 9, 9, 9. All the 10s are going to stay. 11, 11, 11. Okay, stat calc 1. Mean is 10. Standard deviation is much smaller at 0.87. That's a big difference in standard deviation. This guy's standard deviation was much smaller than his, so we were correct in our thinking. Standard deviation also gives us an idea of how unusual a data value is. If a data value is far from the mean in terms of standard deviation, then it is more unusual. You can sort of use standard deviation like a ruler. So for example, girls have an average, that's the same thing as mean, height of 65 inches with a standard deviation of 3. So what we can do with that is we can kind of make like a ruler with 65 in the middle. And then 3 is going to be our standard deviation. So what I'm going to do is I am going to add 3, add 3, add 3, subtract 3, subtract 3, subtract 3, and we kind of get an idea of about the locations of girls' heights. Girls' heights are typically about 65, but that standard deviation gives me an idea of about how much of a range we would expect to see in girls' heights. Now, most data never really goes much farther than 3 standard deviations in each direction. And then the standard deviation is the distance between each one of these lines. So, boys' heights have a standard deviation, have an average height of 67 inches. Their standard deviation is a little smaller though, at 2 inches. So I'm going to add 2 onto each one of these numbers and then subtract it off. That's my standard deviation. So the distance from here to here is 2. Okay? And now this gives me an idea of what I expect boys' heights to look like. Which is more unusual? A girl who is 59 inches tall, so let's mark her off. She'd be right here. Notice that she is 2 standard deviations below the mean. Or a boy who is 71 inches tall. So we'll mark that off. And notice he is 2 standard deviations above the mean. And since both of these are 2 standard deviations away, both of them, then they're both equally unusual or usual. They're equal in their unusualness. Doesn't matter that one's taller or one's smaller, that doesn't matter. They're equal in their unusualness. Now, if the boy would have been at 73, that would have been more extreme because that's farther from the mean than the girl was from her mean. If the boy stayed at 2 and the girl went down to 3, then she would be more unusual. So the farther from the mean you are, the more unusual are. But since both of these were 2 standard deviations from their mean, neither one is more unusual or usual than the other one.